whole conference about continuous delivery? Seriously? Isn't continuously delivering software in 2021 a no-brainer already? Releasing dozens times a day? Easy peasy, piece of cake, right? But what if something breaks? Well, no problem. We have all of them observability tools, right? Logs, metrics. We'll find the problem. We have the dashboards, we have the alerts, and we'll fix it like 1, 2, 3.
Can we fix it? Yes, we can.
Could you sense the sarcasm in what I just said?
This is an important question, by the way. So if you could identify the sarcasm, please send a plus to the session chat. And if you couldn't, please send a minus.
I'm pretty sure you could. We folks in tech are very good at sarcasm. We like sarcasm. Understanding its subtleties requires sophistication, so it makes us feel smart and amused at the same time. But do you know what psychologists tell us about sarcasm? They say it's a maladaptive coping mechanism for those unresolved anger or frustration. Dr. Clifford and Lazarus once said that sarcasm is hostility disguised as humor. And if we look further into workplace psychology research, we'll find out that actually sarcasm is a clear warning sign of burnout. Have you ever been emotionally burned out at work? Well, according to statistics, if you've been in this industry for 10 years or more, there's a higher than 70% chance that you've been burned out in one way or another. I've been there. I was also one of those who burn out really hard. It took me more than a year of therapy to fully recover. I don't want even to go there now. Let's instead talk about what's causing burnout. According to Christina Maslach, who is one of the top experts on this subject globally, there are a number of contributing factors, with the main contributing factors being overload, too much work, perceived lack of control, lack of fairness, lack of appropriate reward, toxic or alienating community, and finally, values mismatch. Now, admittedly, most of the factors contributing to burnout are social factors, and that's of ultimate importance. We cannot even hope to solve the burnout problem by technology alone. If you have a toxic team or unfair treatment, technology won't help here. But still, this is a technology talk, and I do believe that technology can help us with at least two of the factors contributing to burnout, namely overload and perceived lack of control. Now, let me describe the state of affairs in any moderately advanced tech company running on cloud-native stack today. So you probably have your cloud in 2 or more regions, and you're utilizing 5 to maybe 20 cloud provider managed services. You probably have some kind of a CI pipeline setup, and maybe, even maybe, it ends up with each of your commits being pushed to production, even though that would automatically put you in the elite echelon. You're also probably paying for some kind of an observability tool to push your logs and metrics to, and you maybe have some dashboards set up so you have something to stare at when things break. And you know they will break, because as you continue building, the entropy keeps creeping in, the tech debt starts looming, new services get added, manual fixes get applied and never copied to code. How many times has it happened to you that you're fairly certain that a feature was implemented, only then to find out that it was never actually merged to mainline. And in that state of constant uncertainty, we're supposed to keep quiet and push changes into production. If you ask me, that's a certain path to emotional overload, perceived lack of control, and finally screaming, "The roof is on fire!" But what's there to do, you may ask? Well, looks like the only way to continuously deliver software to modern, complex, distributed platforms and stay sane is to make our systems themselves smarter. The manifesto of chaos engineering, the so-called principles of chaos engineering, tell us in non-ambiguous terms our systems are too complex for us to reason about, and unpredictable crap will invariably happen. And guess what? In large part, this lack of certainty, this unpredictability is caused by the change that we introduce. And the rate of uncertainty grows proportionally to the rate of change. So continuous deployment causes instability in our systems. What else is new? You already knew that, right? That's probably why you are not doing continuous deployment. That is the main barrier, isn't it?
Why the angry face? Did I touch on a painful subject? Did I rub salt on your wounds?
And you know what the funny thing is? We keep lying to ourselves by saying that we can lower the level of uncertainty by investing more in our CI. As one customer recently told us, we don't do CD because we don't have tests. And that's not coming from a startup that was founded half a year ago. That's a company that's been running for about 10 years already. For one thing, if you haven't been doing testing for 10 years, there's not a very high chance of you starting doing testing tomorrow with a high enough level of certainty that will allow you to deploy to production, right? But even if you're saying to yourself, one day we'll have enough testing and we'll be able to deploy to production with certainty, I have one message for you. That's bullshit. The only way to actually test things in production is, well, by testing production. We have to be able to test and verify our deployments the same way as we test and verify our code.
So production testing is not a new idea, but the interesting question to ask here is, first of all, how many of us here do smoke testing of our deployments? So if you do some kind of a smoke automated testing of your deployments in production, please send a yes to the session chat and maybe some details about what you're using for that, how you're doing that. And if you're not doing that, then let's start thinking why. What are the barriers, right? Okay, let's continue.
And this brings us to the topic of resilience. You see, we've been studying the subject of building resilience and adaptivity into our systems for a long time. A number of patterns have evolved, but basically it all comes down to the system being able to autonomously do two things. One, identify a problem, and two, deal with the problem. Today, all this is the work of human operators. So we define what normal is, and then we collect logs and metrics to help us make sure that the system behaves the way it should. And if we're really knowledgeable, we also succeed in defining good alerts that wake us up when something breaks. All this is tons of work, of course, and it's also usually done as an afterthought, unless you have a very strong and experienced and, importantly, non-overloaded SRE team. And how many companies today can boast they have that? So let's say we've identified the problem. Now comes the part of dealing with the problem. This would involve analyzing all of the options of getting back to normal and choosing the best, the most appropriate option for the situation at hand. This is the basics of incident response, and today most of this is largely manual, uncodified, unautomated. Now let's imagine a better world, shall we? A world in which each time a system changes, each time there's a new deployment, a configuration change, an infrastructure upgrade, there is an automated verification process that gets triggered and verifies that the system still behaves correctly. And if there's a problem, there's also an automated remediation process that gets kicked off that starts iterating on all of the possible solutions for the problem at hand, and it can find and apply the best solution. Such a solution could be a rollback, but it doesn't have to be. We all know that the automated rollback is seldom the best option. So instead, it could be a reconfiguration of some kind, a resource reallocation, you name it. By the way, I'm not making this stuff up. These self-adaptivity, self-healing properties are omnipresent in the systems we're running today. The most trivial example would, of course, be autoscaling. So we identify certain resource is under or overutilized, and we kick off the autoscaling process in order to fix this. We can also see this in networking with all kinds of resilience patterns, such as exponential backoffs, fallback servers, bulkheading, etc. And of course, the reconciliation patterns we find in Kubernetes also have these self-healing properties. They also implement this, albeit in a very dumb, primitive way. So there's a replica set. It identifies that there are more replicas than needed or not enough replicas, and it reconciles this. It heals the deployment in order to have the defined number of replicas in order to bring it to the desired state. And we also have the rolling update strategy, the default deployment strategy in Kubernetes, actually. That, and then we have the aliveness and readiness and startup probes that all verify the health of our pods and make sure that the deployment progresses in a safe, incremental way. And then for more complex scenarios, there's the operators pattern, of course, which adds a management layer that automates the operation of complex, stateful, distributed systems. And this includes such self-adaptivity, self-healing scenarios as failover, resharding, etc. Trouble is, all these are today either very narrowly resource-oriented or have to be specifically implemented in code for a given system. But what if we could have a generic way of defining the desired system behavior and possible remediation steps, and then we could let our system adapt to whatever problems may arise? What if we could deploy our code on a Friday and confidently go home knowing that our system will be able to handle whatever adversity we throw its way? Sounds like a dream? Or maybe the future we're already building. It all starts with progressive delivery patterns, of course. Progressive delivery, anyone? So I've already mentioned the rolling update strategy, but if you want to go further past the basic health checks, we need to be able to implement such strategies as blue-green, canary, A/B testing, maybe feature flagging. All these require us to be able, again, to define what the desired behavior of a system is and what to do when the actual state doesn't fit our expectations, whether to go on with the rollout or pause or maybe roll back or maybe take some other action. The actual implementation of this is based on our traffic shaping capabilities, the system component observability, and finally the mechanics of the rollout. The approach was originally pioneered by Netflix Kayenta and is now being brought into the cloud-native world by such systems as Flagger, AlgoRollouts, and our own Birdwatch. Now, what we're now starting to realize that in order to enable the constant influx of change in cloud-native systems, we need to be able to provide this adaptive capacity not only at the deployment time, but also at runtime. A change in a system can actually have a delayed effect. Imagine, for example, a small memory leak that originally gets unnoticed, but brings the whole system to a halt after a few hours of work. Therefore, we need not only continuous verification, but also continuous remediation processes in place. And we are already starting to see the first glimpses of this in many of the projects presented at this conference, in this foundation. For example, AlgoRollouts brings us such abstractions, useful abstractions as experiments and analysis that allow us to verify the system state, to identify problems, and to experiment with alternative versions and configurations. And of course, these ideas are based on the ideas originally introduced in Kayenta, which is a sub-project of Spinnaker. Captain provides another interesting approach called, actually, remediation, which allows us to define a problem and then define a number of actions that we can apply when a problem is identified, with actions being customizable via action providers that we can create as needed. Now, an attentive observer will probably notice that all this somehow intersects with another modern operations approach that has seen some uptake recently, namely Runbook Automation, which is more or less similar to the operator's pattern, taking well-known operational approaches and codifying them for automated execution. Originally, this was done with Rundeck, config management tools, maybe even Jenkins, and is now being brought into modern systems by such vendors as Stackpulse, Blameless, Fire Hydrant. Basically, it all comes down to defining the desired system behavior in the form of service level objectives, maybe SLO, bring this into the SRE jargon, and defining some service level indicators that allow us to measure the system's behavior, right? And define and automate the workflows that we need to invoke in case an SLO is violated.
Here's another interesting question for you for the session chat. Are you defining the SLOs, and do you have the defined SLIs for the services you are building and running? If you do, send a plus. If you don't, send a minus.
And while all these systems are great SRE enablers, they all, in my point of view, miss a certain important component. They all enable humans to do resilience instead of enabling the systems to do resilience in an autonomous way. And the key to that is, as you can guess, machine learning, right? The system has to be able to learn its own behavior, to learn the behavior of its components, to learn the behavior of the system as a whole, to analyze the semantics and the impact of change, and to iterate on possible solutions to a problem until the SLO is achieved. This is the way forward, and this is what we're building at Canarian. And if I got you curious, I'll be happy to take your questions. Feel free to challenge me in every possible way, and let's see how resilient I am, how well I can handle unpredictable, unexpected adversities that come my way. See you in the Q&A area. Bye.
So after finishing the talk, I realized I didn't introduce myself. So in case you do want to talk to me and ask questions, here is who you're going to be talking to. My name is Anton Weiss, and I'm the CEO of a software delivery consultancy company called Automato, where what we do is help businesses, large enterprises and small startups to deliver software in the best possible, the most effective way. Basically, we do DevOps and cloud native. And I'm also the host of a show called DevOps Shorts, the link to which I'll be providing. And today, I'm also one of the co-founders of an exciting startup called Canarian, which is building the very technologies that I was talking to you about in the talk. See you in the Q&A area. Bye. This time, it's really bye.
The haircut. Oh, that's easy. You do it at home. But you need to have hair for that, of course. Well, right now we're developing the prototype. We had a bit of a hold up at the company about half a year ago. And well, we had some organizational issues, so it's been a little bit slow, but we know the way we're going. Actually, it's not only us, the whole industry is looking into that direction. And so I was recently looking at what OpsMX, who are sponsoring the conference, have to offer. And they're also talking about continuous verification. So they have that system called Autopilot. And still need to see what it offers, but it's built upon Spinnaker. We're not building upon Spinnaker. We are interfacing with Argo and its family of projects right now, and building our own open source that will provide a continuous remediation controller for your Kubernetes cluster right now. Basically, the challenge we see is, again, with providing a usable interface for defining the service health criteria.
because this is the hard issue. This is the hard issue with all kinds of progressive delivery controllers today. Whoever tried to define Canary rollouts for their services realizes that the hard part there is defining the query that will provide good criteria for your service health. And we're looking into improving the usability of this, first of all. Yeah, that's actually, burnout is a subject for a whole another talk here. But what helped me the most is opening up to folks talking about how I feel, offloading some of the responsibility to others in the company that I was at the same time. And somewhere realizing that the more important things in life lie outside of the cycle of work. So yes, work-life balance is important. I did realize how important it is to define the limits to where you allow work and work-related stress to influence whatever happens in your life. So Pavel Rain, regarding generalization across industries, you mean the generalization of service health indicators, service level indicators? Again, the intention here is not to provide some general, queries that will show you how good your service is behaving. It's more about providing a usable interface for defining this, and also some algorithms for collecting the indicators related to your service behavior across your observability solution, and defining some kind of a baseline. Okay, so this definitely can be automated. Without, diving too deep into the algorithm. Well, Oleg, I think my main tip about disconnecting is you need to realize that you have the right to disconnect, and the world won't end if you just go offline for a week or even for a month. Again, if your responsibility is being out there, then, well, the right thing would be just go to your employer and whoever and say, I just can't be out there anymore for the next month. Somebody needs to step into my shoes. Okay, so I'm getting the notice here that the session is scheduled to end in 2 minutes. Thank you, folks. It was great fun delivering the talk, and thank you for the good questions. See you around.